A chemistry student was given a mini project to analyze for ethanoic acid in a 100-gram sample for a marine plant extract. The student conducted a titration and found that it took 20 ml of 0.625 molar sodium hydroxide to neutralize 25 ml of solution of the marine plant extract. We are required to calculate the mass of ethanoic acid in the sample and also the percentage of the ethanoic acid in the sample. We begin by writing a balanced chemical equation for the reaction between sodium hydroxide plus ethanoic acid, and this will give us sodium ethanoate plus water. Just like a normal reaction between an acid and a base, where the product is a salt and water. Ethanoic acid is a weak acid. Then we calculate the number of moles of sodium hydroxide that reacted. Since the volume we used was 20 ml of a concentration of 0.625 molar, so number of moles here we will get by volume of sodium hydroxide used multiplied by the concentration of sodium hydroxide divide by 1000 ml. Remember here that the molality means that we have moles in a liter, where a liter can be also written as 1000 ml or 1000 cubic centimeter or 1 decimeter cubed. Therefore, the volume used is 20 ml multiplied by the concentration is 0.625 molar all over 1000 ml, and therefore we will have the ml and ml cancelling. This will give us a molality of 0.0125 moles. Number of moles of ethanoic acid that reacted. So we used a volume of 25 ml, and therefore we are going to use mole ratio. From the balanced equation, we can tell that the coefficient of sodium hydroxide is 1 and the coefficient of ethanoic acid is 1. So this means that the mole ratio is 1:1. Therefore, the number of moles of sodium hydroxide reacted with an equal number of moles of ethanoic acid. This means that the number of ethanoic acid COOH is equal to the number of moles of sodium hydroxide, which is equal to 0.0125 moles. Okay, now we calculate the mass of ethanoic acid. We know that mass is given by number of moles multiplied by relative molecular weight or relative formula mass, RFM. The LFM of ethanoic acid, we have CH3, COOH, we have 2 carbons. Carbon has a molecular weight of 2, but there are 2 of them. Then we have 4 hydrogen, so that will be 4 times 1. Then we have 2 oxygen, that will be 16 by 2. And this will give us a total of 12 times 2 plus 4 plus 32. that will give us molecular weight of 60 grams per mole. Therefore, the mass of ethanoic acid will be the number of moles, which is 0.0125 moles multiplied by 60 grams per mole. So the mole here will cancel and we'll be left with 0.0125 multiplied by 60 to give us a mass of 0.75 grams. So that's the first answer for A. For part B, we are required to calculate the percentage of ethanoic acid in the sample. Remember that ethanoic acid was in a sample of a marine plant extract, which was 100 grams. Therefore, the percentage mass will be given by mass of ethanoic acid over mass of the sample multiplied by 100%, and therefore we have 0.75 grams all over 100 grams. This was the mass of the sample multiplied by 100%. So 100 will cancel, and here gram and gram will cancel, and we'll be left with 0.75%. That is our second answer.